Write question 1. What are the characteristics of a quadratic function that you can determine from its equation in standard form? An equation for a quadratic function in standard form is y equals ax squared plus bx plus c. You can determine if the parabola, which is the graph of a quadratic function, if it opens up or down. The number that's in front of the x squared term, and in the equation you'll see that is an a. If that a is positive, then the parabola opens up. We say the parabola is concave up. And if that number in front of x squared is negative, then we say the parabola opens down or is concave down. The other thing you can see in standard form is the y-intercept. The c, which is the number at the end of the equation in standard form, is the y-intercept. We sometimes just say y is equal to c, or if you write an ordered pair, it's 0c. Write question 2. Describe the characteristics of a quadratic function that you can determine from its equation in factored form. In factored form, you have y equals a, and in parentheses, x minus r subscript 1 times x minus r subscript 2. In this form, you can determine if the parabola opens up or down. It has an a in front, and that a is exactly the same number that appears in standard form. If the a is positive, the parabola opens up or it's concave up, and if a is negative, the parabola is opening down, and we say concave down. The other thing you can determine are the x-intercepts, or the zeros of the function. So you'll notice that the r1 represents the x-coordinate of one of your x-intercepts. We call these roots and zeros also. R2 is the other x-intercept of your function. Practice question 1. Analyze the quadratic function f of x equals 4x squared minus 12x plus 8. Identify the quadratic function as standard form or factored form. So this equation is in standard form. You can recognize that because it has your x squared term first, your x term second, and a number last. You may have fewer than 3 terms, but you must have an x squared term in standard form. B, does the quadratic function have a maximum or a minimum? Well, since the a is positive, that's the 4, that means the graph opens up, and this is the answer to question C, because 4 is positive. And if it opens up, then we have a low point called a minimum, or the vertex of that parabola would represent a minimum. And then next is D, determine any x-intercepts from the equation only and without graphing. So notice the 8 at the end represents the y-intercept of the function, so you can write the ordered pair 0, 8. You can also just write y equals 8 for your y-intercept. Practice question 2. Analyze the quadratic function g of x equals negative 1/2 times the quantity x minus 2 and then times the quantity x plus 5. A says identify the quadratic function as standard form or factored form. This is factored form. In this, the two factors are two binomials, x minus 2 and x plus 5. B, does the quadratic function have a maximum or a minimum? Well, in this case, we have a negative number in front, negative 1/2. So on answer choice C, that's telling us that the parabola opens down, which means the answer to B is maximum. The vertex will be like the highest point on the parabola. Finally, D, determine any x-intercepts from the equation only, and this is without graphing. So of course we can look at it in a calculator, but we want to be able to answer this without the calculator. So notice the equation has x minus 2. Well, if you put a 2 in place of x, 2 minus 2 is equal to 0. So 2 is your x-intercept. And then x plus 5 is your other factor. Well, if you put a negative 5 for your x, negative 5 plus 5 is equal to 0. So we call those zeros. When we plug a number in and get a 0 out, we call that x value a 0 because it produces an x-intercept on the graph. So your x-intercepts are 2, 0, and negative 5, 0. Practice question 3. Analyze the quadratic function h of x equals negative 2x squared minus 4x plus 6, and it says to use the Desmos Calculator. So if you'll click on that link, you can open up the Desmos Calculator, and then that's what I'm going to do here. I'm going to type in this function h of x equals negative 2x squared minus 4x plus 6. All right, now to work on this window a little bit, you can drag it around. You can leave it like it is, but I'm going to clean it up a little bit. Let's go to our wrench, which gives you your settings. You can turn off your minor grid lines. You can change your x scale and add a label. I think I'll change my x minimum to negative 4. And my x maximum to positive 2. I don't think I need to go past 2. And then we'll count by ones. And on the y-axis, I think what I've got is actually pretty good. So let's just leave negative 2 to 10. And let's count by ones. If you'll click on projector mode, it'll bold your graph. And then you can move it around. Now what's great is I can click on these points, like this point, and notice how it highlights those points. If you'll click them again, it's going to open up, it's going to show you what all these points are. So let's go back to the assignment and see what the first question says. It says analyze the quadratic function. Well, the axis of symmetry in this case will be x equals negative 1 because notice the x-coordinate of my vertex is negative 1. The second question says what is the vertex of the graph? Well, notice the vertex is highlighted and I've labeled that. So the x-coordinate is negative 1, the y-coordinate is 8. So you would write the order pair negative 1, 8. Describes the intervals of increase and decrease. Well, the function, you'll notice, is increasing until it gets to the negative 1. And then it's going to decrease after that. When we do intervals of increase, please know you only use your x-coordinate to describe that. So x is increasing, the function is increasing as x is less than negative 1. And the function is decreasing when the x values are greater than negative 1. To use technology, well, we've kind of used technology for this whole problem, but the x-coordinates of your x-intercepts are negative 3 and 1. So you can write these order pairs, or you can write just x equals negative 3 and x equals 1. And then finally, what is the average rate of change between the zeros? Well, if you take the y minus the y, which is 0 minus 0, and then your x minus your x, which would be 1 minus negative 3, you'll get 0 divided by negative, positive 4. But you are going to get a rate of change of 0 because this is horizontal. If you go from negative 3, 0 to 1, 0, that's a horizontal line. So the rate of change will be 0 for that problem. And then finally, to write your equation in factored form, you'll notice in the original equation, the x value, or the a value, which is in front, negative 2, is going to stay the same. So in your equation for answer F, put h of x equals negative 2, and then your x-coordinates were negative 3 and positive 1. So that makes your factors x plus 3 and x minus 1. And a really good way to check your answer is to go in here and type your function. So I'm going to show you the same equation in here. So I'm going to put negative 2, and then I'm going to put x minus, x plus 3 and x minus 1. And it'll produce another graph just like the other one, except now it's blue. So it's showing you that it's this second one. These are actually the same function. If I click on this one, the red one will show. If I click on this one, the blue one will show. They're really the same function. Practice question 4. Analyze the quadratic function h of x equals 1/2 x squared plus 2x minus 6. So I've gone to the Desmos graphing calculator and I've typed in the function h of x equals 1/2 x squared plus 2x minus 6. So once that's happened, you can adjust your window. You can zoom in and out. But I'm going to go ahead and highlight this x-intercept, this vertex, this y-intercept, and this other x-intercept so that I can see these points. So the question that it's asking first is identify the axis of symmetry. Well, you can't really see the axis of symmetry, but it goes through this vertex. So it would be a vertical line straight down the middle. So the equation of that line is x equals -2. So the next thing it asks is what is the vertex of the graph? Well, I don't have the right vertex here. It's actually -2, -8. So let's fix that. Describe the intervals of increase and decrease. Well, this time the parabola is increasing on the right side of the vertex. So you would say as x is greater than -2, then the function's increasing. And then on the left side of the graph, the left side of the parabola, the function is decreasing. So on your answer choice C, it is increasing when x is greater than or to the right of -2, and it is decreasing when x is left of or less than -2. And then D says use technology to find the zeros. Well, I have the wrong zeros in mind. Let's see, I need -6 and +2. So let me change this to -6 and +2. So those are the zeros. And then finally, it says, what is the average rate of change between the zeros? Well, just like before, the y's are both 0, so there is no change in y. The x's are -6 and 2, so the change in x is 8. Well, 0 divided by 8 is 0, so there is no rate of change or 0 rate of change in this instance. So you should put 0. And then finally, to write a function, well, this is not correct. Let's go back up to the top. I do need the 1/2 in the front, so that is correct. I do need x plus 6 because I have a -6 for a 0, and I need an x minus 2 because I have, let me fix that, I have a +2. So notice if I put a -6 in place of this x, I would get a 0 out. So that works. And if I put a +2 in place of the second x, I would get a 0 out. So that would be the function in factored form. Review question 1. Marcus wants to create a new enclosure for his dog. The current enclosure is rectangular with a perimeter of 6 feet. And the perimeter of the new enclosure, it's still going to be rectangular, by the way. It will be 3 times larger than his former enclosure. So here we have a picture of a rectangle, and so the width of this enclosure is, we're going to call that x. The new enclosure is 3 times this perimeter, so its perimeter is 18. So what you want to start with is the formula 2x plus 2l is equal to 18. That's because you would add 2 lengths and 2 widths together to get the total perimeter of 18. Now solve that equation to find the length, solve for L. So I'm subtracting the 2x from both sides first. 2l equals 18 minus 2x. And then divide all 3 terms by 2, and you'll get L equals 9 minus x. Okay, so now what is the area? Well, the area of a rectangle is just length times width. So x is the width of the rectangle, and then the length is 9 minus x. So just put parentheses around that. Now we're going to go and use the Desmos Calculator for this. So go ahead and go to Desmos, and let's type in a of x equals x times 9 minus x. Now when we do that, our new domain here should be from 0 to 9, because at 9 you're going to get another 0. So this works pretty well, but it is way too tall. So let's go to our y max, And let's change this 11.2 to something way bigger. Let's say 30. And I could make this like -5. Maybe 25 is better than 30. And I'm going to count by 5s. So that does look a lot better. If you want to kind of zoom in, you could make this X max a little smaller. Maybe make it 10. And this X min, we can make it like -1. And that looks a little nicer. All right, so here's my parabola. You can zoom in and out. So the question was, what is the maximum possible area? So in this case, I would want the highest possible point. So if you'll just click up here close to the top, it's going to give you a point. Click it again and it'll display the ordered pair for that point. So notice the highest point on this graph is the vertex, and it represents a maximum. The y value is going to be the height, or the h of x, and this, or a of x. I shouldn't have an h up there, but this is a of x. And this area is 20.25, and our units were feet, so we're going to put 20.25 square feet. So I've made a little picture of this for you, and I also labeled the 2 X-intercepts, though that's not part of what it asked for, so I don't know that we need that. All right, it asked for the dimensions of the largest possible area. Well, we know the largest area was 20.25, but the dimensions would be the width and the length. So the width is the x-coordinate of this point here. To get the length, you would just take your formula for length, which is L equals 9 minus 4.5, and that's also 4.5. So it's interesting, but the length and the width are both 4.5 feet. So the dimensions would be 4.5 by 4.5, or actually a square.